It's Friday, October 20th, 2023. Welcome to the weekly news. Hey guys, it's Josh from the WL Tech blog, and this is the weekly Linux and open source news. Thanks for joining. This week it's a little bit quieter on the security front, but we've got a few things to talk about there in addition to some more positive updates. So let's get started. Ubuntu 23.10 re-release. This is a weird one, but I'm going to call it a security issue. Evidently, before the Ubuntu 23.10 final images came out, a bad actor involved with their translation system managed to replace a bunch of normal installation messages with racial and ethnic slurs in Ukrainian. Once alerted to this, Ubuntu pulled those images offline and has since released a fresh set. But it is a clear demonstration that even an organization that generally has their act together can have enough of a blind spot to allow in malicious content. Will this affect user trust in the Ubuntu distro? Hard to tell yet, but Ubuntu has a strange relationship with the community as it is, and it certainly won't help. Linux fixed crash bug when unplugging Logitech receivers. This is an embarrassing bug, but it's been fixed. Evidently, if you were to unplug certain USB receivers for wireless Logitech devices on recent kernels, you could experience a system crash. The bug was introduced around kernel version 6.4, and the fix will be included in 6.6. Distributions with affected kernels are backporting fixes. Online forums really embrace this story as it sounds silly, but bugs are bugs and bugs get fixed. It's also brought up the whole microkernel versus monolithic kernel debate, which is probably healthy. We'll talk more about microkernels shortly. OpenBSD 7.4. For our BSD fans, exciting news as Theo Durat and team has released version 7.4 of this security-focused BSD operating system. In addition to the usual version bumps of included userland software, there's some great improvements at the system level as well. A few security points in there, such as kernel mitigation for AMD's ZenBleed, lots of ARM64 changes for better compatibility with Apple's M1 and M2 processors, and dozens of minor improvements in SMP, kernel debugging, and virtualization. You also get a bump to the Linux DRM stack from 6.1.55, which adds supports for more modern video devices. If you're a BSD fan or just looking to expand your operating system toolbox, it's a great time to try OpenBSD. Minor updates. Last week we got version 2.4.58 of the Apache web server, which addressed some HTTP 2 issues, including the rapid reset exploit mentioned last week. Still no update from Nginx, who's taken the position that a good rate limit config is suitable to handle it. The uutils project, which is creating replacements for core Unix utilities but written in Rust, has released 0.0.22 of their core utils package. Aiming to be an MIT-licensed drop-in replacement for GNU Coreutile, which provides the basic command line utilities for handling files and more, they're mostly feature-complete but still progressing to pass the GNU Coreutile test suite. I'm a big fan of replacing C code with safe languages, so projects like this make me happy, and I'm excited for that 1.0 release. GCC announced the close of the new feature window for GCC 14 being November 19, and after that the belt tightens more and more to restrict it to just bug fixes for a few weeks, and then finally to just documentation and regression fixes before the January release. We should start to see GCC 14 and distributions next spring, possibly even the next Ubuntu LTS. Editorial, Microkernels. In the 1960s, computers still hadn't become general purpose from a practical sense. The hardware was surely capable, but computers had a job to do and operating systems were there to facilitate doing that job. The division between kernel and userland was still being worked out. It was the Wild West out there. Operating systems of the day were generally single-task, although time-sharing systems might present the illusion of rudimentary multiprocessing, and CPUs didn't necessarily even have the concept of privilege rings or executive functions. In the mid to late 1960s, a Dutch computer company was frustrated by the fact that every installation they would do would require different kernel code, as the peripherals that would be connected and the features they needed support would be fairly unique to each customer. This prompted them to develop what is generally considered to be the first microkernel, with a small nucleus that would manage the most basic tasks of keeping the computer running and support up to 23 other processes running at lower privilege levels, using that nucleus to communicate between each other with a defined interface. This allowed them to keep that nucleus small and consistent, moving the code that was more specific to each customer into their own modules. Now, at the time, this didn't bring all the advantages we associate with microkernels today, but it was a good first step that demonstrated that some of the key pieces were feasible. The modern definition of a microkernel includes that communications layer between processes, generally called message passing today, and adds several other high-level features. Taking advantage of things like CPU privilege levels and exceptions, microkernels can implement things like device drivers entirely in userland, communicating with the nucleus when necessary to do privileged things. On paper, there are many benefits. For example, if a device driver crashes, it can simply be restarted without affecting the nucleus or other drivers. Of course, this also means you can reconfigure a driver and reload it, or even upgrade it on a running system without needing to take the system down for a reboot. Since your privilege code is so much smaller and less complex, the attack surface for security problems is also much smaller. These are all great things, but it's not all roses with microkernels, and the elephant in the room is performance. Passing a message around is by nature more costly than simply doing something directly. Taking a quarter out of your pocket, flipping it, and getting the result is much faster than calling a friend and asking them to do each of those steps and read you back if it was heads or tails. Of course, computers kept getting faster, and when measured by a stopwatch, those delays would get smaller, but they stayed about the same as a percentage of speed when compared to a monolithic kernel. In a monolithic kernel, all those components are grouped together, and an unhandled problem can crash your entire system. The Logitech USB receiver bug we talked about earlier is a good example. You wouldn't expect that unplugging your mouse would be able to do it, but the underlying mechanism that handles it had some flawed logic, and you get what you get. The goal for any kernel is to handle every possible case and prevent crashes from happening, but sometimes it does happen, and in a monolithic kernel, you're often looking at a reboot. Famously, when Linus Torvalds was first building Linux, he got into a public debate with Andrew Tannenbaum over the merits of microkernels versus monolithic kernels. Andrew would state that microkernels were the clear and obvious choice, and that a monolithic system like Linux was obsolete. Being a university professor at the time, Tannenbaum was also the creator of the Minix operating system, a microkernel-based platform designed for teaching operating system designs. From a practical perspective, Minix wasn't particularly advanced or useful outside of the classroom, being purposely limited in scope so that students could understand it. It lacked things we would take for granted today, such as multi-threading, networking, graphical displays, and more. Linux, on the other hand, was feature-rich, intending to provide the full experience of a Unix workstation on a personal computer. The debate got fairly heated, but ultimately the outcome was that Linux and Minix had such different goals at the time that using them as arguing points against each other just didn't make sense. Of course, Minix wasn't the only microkernel around. Some had great success, such as QNX, which today is most popular in automotive applications, Mach, which was the basis of the hybrid architecture of modern Apple desktop and mobile operating systems, and the L4 microkernel family, which can be found in millions of embedded devices, including wireless chipsets from Qualcomm. Microsoft also briefly flirted with microkernels in the Windows NT era before moving to a hybrid architecture. The choices are fairly clear. A pure microkernel approach brings some real technical advantages, but in many applications, those advantages don't justify the performance difference. In a setting where you're already overpowered for the task, or where safety is the priority, such as most automotive or automation environments, the enhanced protection from a software failure is a pretty easy trade. But that's not always the case. If your PlayStation was 15% slower playing a game, but less prone to rebooting if your game crashed, would you consider that an improvement? How about your desktop PC? When's the last time your system rebooted because of a software failure? Would you take a cut in performance to prevent it from happening? Monolithic kernels aren't these crash-happy things. At least in open source operating systems, those failures are already rare and exceptional enough to have articles written about them. Even in the data center, where failures can be expensive, clustering and failover techniques exist not just for software issues, but also for handling hardware failures, which microkernels can't do much about either. Can you justify adding 15 or 20% more to your infrastructure bill to avoid one unlikely form of extra latency while a node reboots? Wrapping up. Well, those are the highlights from this week. Did I miss something? Let me know in the comments. I'll be posting these videos every Friday. If you've got a great project update that should be featured, put it down below and I'll have a look. Also, if you're a fan of tech projects, come check us out in the Discord. Link's also below. Have a great week, and we'll see you next Friday.